All right, well, good morning to everybody. This is Automating Privileged Identity Management with Lieberman Software. My name is Phil Lieberman, and I'm the president and CEO of the company. I'd like to go ahead and talk a little bit about what we're going to be talking about this morning. I have the presentation broken up into three distinct sections. Section one is we're going to talk a little bit about what privileged IDs are, what some of the challenges are for managing them. In section two, I'm going to be talking about our system center integrations as they exist today, both how we allow System Center to gain access to credentials, as well as how we manage the credentials within System Center itself. In part three, we're going to be announcing a new product. This new product is actually an extension to our existing product, and it deals with the idea of automation and orchestration, and the idea about doing this at scale at both a public and a private cloud implementation. So this is also based on some work that we've been doing with some large cloud providers that you do know. So the beginning, introduction. So what are privileged identities and why should you care? And what is the nature of the threat that you face if you don't manage them? And what's the big deal about them? Privileged IDs are really the most powerful accounts you have in your organization. These go under names such as root and administrator, but they're not always just the root and administrator accounts in your organization. They can be regular accounts that just simply have some kind of elevated privilege. So these problems, or the problem and the challenge of these particular accounts, is that because of their privilege, whether they're administrator or not, they do have access to sensitive data. And if they're uncontrolled, there's issues, and if they're never changed, that is, the password is never changed, then you have problems. The other issue is the issue of accountability, and that is that if everybody's got a spreadsheet, and on that spreadsheet is the password to every machine in the company, and the passwords on that spreadsheet never change, and somebody leaves the company, you have a problem. Because they can get in not with their old user identity, but they can get in with a privileged identity potentially. The other part about this has to do with accountability, also known as attribution. Attribution means that if you use an account like administrator, but your name is Joe, in the logs, all I'll see is administrator. I won't know that Joe actually used administrator. And so the problem is that you want to have attribution. You want to know who's done what. But if you're using a generic account like administrator or root or enable, you may not know that. And so we're going to talk about some mechanisms to create that attribution layer so that you understand who's using one of these particular generic accounts. The nature of these accounts are known to everybody. They're part of every regulatory framework. And the management of them is difficult, especially if it's being done manually. So these accounts are in a lot of different places. These particular accounts are located on your servers, your workstations. They go under many different names like root or admin or super user. Here's a thing that you might be surprised at. You think of things like Active Directory, or you think of things like the local SAM database of your machine as being the only place where a username and a password is stored. That's not really true. It really goes much deeper than that. Specifically, think about your databases such as SQL Server and others. They have built-in credentials that can be used for local access on those particular databases, and those credentials might be in connection strings also that are spread throughout the enterprise. But it goes further than that. There's also middleware, whether you're using IIS or WebSphere or WebLogic or JAAS or SAP or applications. They also have embedded credentials too. And the interesting element of all of this is that if we think about today's cloud, or we think about today's virtualized environment, we also have hypervisors which also have credentials in them. In fact, there's an entire stack. I've got a really nice graphic coming up where we'll actually show you all the places where credentials are embedded. So here's the problem. If you take a typical server and it's filled with IDs and it's filled with places where those IDs are being used, and you're being told you have to change the password every so often, and you have machines coming and going, this is kind of a hard thing to deal with. So some people deal with it via scripts. Well, that's fine as long as the scripts are kept up to date. They deal with it with spreadsheets. They use vaults, both physical and logical vaults. They try to do it manually. This is also a wonderful job for contractors because it never ends. They use the analogy of it's like painting the Golden Gate Bridge because it never ends. And in fact, since there's an error rate of maybe anywhere from 5 to 20%, if you're going to do 1,000 machines times 5%, at best, is a lot of down machines. So people stop changing passwords as a result because it's error-prone, and it's not a reliable thing to do. So we have an alternative, and I want to talk about that alternative this morning. In fact, a number of different alternatives. So let me step back for a moment and let me give you some definitions. And these are common misconceptions that we see with many clients that we work with. They say, I don't need to deal with privileged identities because I have a provisioning system. Whoever you want to talk about for the provisioning system, it could be FIM, it could be a script that you write. And when we talk about provisioning, we're talking about provisioning of users. This is sometimes called identity and access management, IAM, or generic IAM. The management of regular user accounts, somebody joining the company, somebody changing roles, somebody leaving the company, that is its own area. We don't get involved in that. That's fine. That adds things into AD, takes things out of AD, changes attributes, all good. Privileged ID management is a different entire area of identity management. It deals with administrator controls or administrative credentials. It also deals with service accounts. These are the accounts that are not normally used by a human being that are also used not only as proxies, but are also used as break-fix accounts to let you get in, install device drivers, repair the machine. So PIM and IAM are two different areas. We're going to be talking this morning about PIM. So let's talk a little bit about the solution and some of the things you need to do in order to achieve decent privilege identity management coverage. First is you have to find all of your machines. You have to find where the accounts are within those machines, how those accounts are being used. So you need to take an inventory of every AD domain you have, as well as every machine you have, and pull every machine name, every account within each machine, and then crawl every single place where that credential can be used. The next thing is that you do need to change credentials, so part of this regimen is create credentials that are hard to guess, and in fact make them unique on a per machine basis. So you typically want to create something which has random passwords that are generally longer than 14 characters long. And you want to be able to somehow retrieve them as well as store them in a way that is secure. And you also want to make sure that you update them where they're being used. So there's no point in changing a password and not changing the service, for example, that uses it. So you've randomized them, you've changed them. Now there does come a time when either an application needs the credential or you or somebody on your staff needs to gain access to the credential. So rather than having a spreadsheet that everybody can see, you need to have a way to make sure that only the right person has access at the right time to only the things that they need to see, and only for a limited period of time. And when that time is over, that password needs to change automatically and everywhere where it's being used. All right, so the other part about this is auditing and alerting. What auditors want to see is who's done what, why, when, and where, which means looking at things like trouble tickets, also understanding the behavior of users, also understanding the usage of these particular accounts. Also looking for aberrant behavior is another part, which is if somebody is gaining access to a system at too high of a frequency, or something looks wrong with the IP address that they're accessing our system from, these are things that you potentially might want to be alerted on. So the number of things that you need to deal with, as I said, is pretty broad. You think of these privileged identities, so we've talked about AD. We've talked about, well, AD is a form of LDAP, so there's a lot of LDAP directories out there and Kerberos providers of authentication. But these are in other places too. You'll see these credentials are embedded in things like routers, in switches. And here's another interesting one. Most modern data centers today use lights-out cards, like DRAX from Dell, ILOs from HP, or generic IPMIs such as might be used in Cisco. Each one of these devices, that is, each lights-out card, is usually running a little embedded version of Linux or some other operating system, and it has its own ID. So consider for the moment that if you've secured all of your Windows accounts, this backdoor into your environment that has the ability to rewrite your BIOS is another credential that also needs to be managed. So let me throw out this hypothetical question or rhetorical question. How many of you actually change the credentials on your lights-out cards? Because these have to be changed because they do give you ring 0 access to the machine, or actually ring -1. The other issue is that if you are using scripts to manage these credentials, IPMIs represent something even more interesting to manage than databases. But the thing that you want to do is you want to scale, because virtual environments can become very large. You need to be able to authenticate across multiple directories. And the other thing is, consider that if these are the keys to the kingdom, do you want to have just a simple username and password, or do you want to use multi-factor authentication? So generally speaking, for things as sensitive as this, you want to implement some sort of multi-factor authentication. So what we do is we implement RSA, we implement Oath, we have an SMS capability, we can use Radius. In addition to that, we also use smart cards. So we're even working with, we're talking to Phone Factor right now about also adding that into our stack. So the idea is understanding and verifying that the person who has access is the right person. The other thing is, it makes no sense to change passwords, store them, and then store them in a way that is not secure. So one of the goals of a solution such as the one that we do is to encrypt the data. So we use all kinds of different ways of encryption. So for example, we use strong algorithms, but we also do software and we also do hardware encryption. So for example, if you want to use a hardware encryption module, also known as an HSM, we can do that with things like SafeNet or with Talus, or if you have some other source of encryption, we can tie into that via PKCS11. So the point is we take all of this data that we're gathering of where things are, we're changing credentials, we're putting them in SQL Server, and then encrypting the passwords in SQL Server. But then when you want to pull them out, we're again doing this in a secure way. But the point is that the passwords themselves are securely stored, which is, again, one of the things that's hard to do in a script, which is how do you securely put things away in a script? I mean, there is a secure store to do it, but then you have to deal with key management and other issues. So the other issue that we're trying to solve here is that we want to deal with the issue of people not changing passwords, and we want to make it easy for people to check out passwords at the right time and for the right reason. So you'll see it's a little hard to see on this particular slide, but what we're showing here is somebody actually explaining why they want access to a system and its credential. And then we tie into trouble ticket systems too, and then in that case, they'd also put in the trouble ticket number. But once there, we then give them the credential. Or consider this for a moment. When we talk about privileged ID management, it's not always about giving up the password. It can also be one of the things we do is escalate somebody. Say, make them a member of the local admins of a particular box for a period of time, and then de-escalate them. We also can do things like RDP them into a box, or we can also SSH them into a box. Now, the advantage of all of these versus the password is that we don't have to disclose the password in order to give them access. So there's many different ways to achieve the objective in addition to providing disclosure of credentials. The other thing is we've been doing this a long time. We've been doing this, since the late 90s. And one of the things that we've been working with some of our DoD customers on is the understanding of behavior in identity. So this is, we find this a really fascinating topic, which is how do you know what is normal and what is abnormal for a user's behavior when they have escalated access? And the funny thing is that if you look at lists and lists of access logs, you really get very little information from this. So identity and access management and business intelligence were never really merged together. There is no concept of these two having anything to do with each other. So we said, well, you know, it would be really cool if we could mine all of this data about what users are doing with their identities and actually chart it, as well as look at things like password ages, chart those, say, in histograms based on date. And we started to see some really interesting patterns in all of this that helped us understand behavior, understand when a user was doing the wrong things, also understanding service problems within the organization. So we actually developed a BI package that would allow us to see these identity usages and also these identity requests from within our application. So visualization of identity and visualization of the way identities are being used, we think, is a really fascinating topic. By the way, you may not be able to see it, but there's like little gray bars in this chart over there. Those gray bars are showing you weekend access. So what we're doing is we're plotting time, that is day of the week, versus particular users, and then if you mouse over, you can see what user is doing what and at what time. So kind of an interesting view of the nature of access. So to step back for a moment, and this slide is, I know, a little bit out of place, but I want to talk a little bit to this because I want to talk about the problem we're going to solve in part 3. Today's hypervisor-based systems are wonderful. We spin up in our data center, we have the ability to do about 150,000 test machines of Windows. And in Linux, we can do about 50,000 test machines in our environment. And these create wonderful, powerful, quick-to-build systems. But the funny thing about all of this is that when you look at this from an identity and access management point of view, every one of those hosts represents a weak spot or represents a place of where identities are stored and identities need to be managed. And we have this kind of upside-down cake of things that you need to manage if you're going to really be compliant and also you're going to be secure. So this goes all the way from the hardware layer all the way up into the hosted virtualization layer. And it's not to say that this is an issue specifically with Microsoft. VMware has the same problem, as does Xen, as does any hypervisor. So literally, this problem becomes bigger because of the number of hosts and the number of things that are being hosted within that particular host hypervisor. So this slide deals with regulatory compliance. If you're saying to yourself, well, you know, okay, so this company's talking about a problem. Okay, they've got a solution. Why do I care? Does this really affect me? Is this really an issue? Well, so what I did is I put up this chart to show you, based on different regulations. These are primarily US-based regulations. This doesn't cover Basel II or ISO 27001. It turns out that the management of these privileged IDs is actually hard-coded into the regulations. So you have to do these things. Now, one thing you can say is, well, if I don't have a solution to do it, you can't make me do it. If it's impossible to do, I'm not going to do it. Well, okay, so we have a solution that deals with it. So now we come up with the question of, how does it deal with each of these different elements? And the answer is, well, it does it. It deals from the discovery. It deals with the correlation. It deals with the change in the credentials, known as propagation, and then also deals with the auditing. So I will say this is pretty hard to do by hand. And a lot of companies have stopped complying with this because it's just too darn hard to do. So with automation, it is possible to do. And in part 3, we're going to talk about like Uber automation, about doing it at the scale of a large companies of the type like you might see here at this conference. So the goal of our product, and I'm not going to get into a marketing pitch on this, is to discover, to randomize these credentials, to store them securely, make sure that only people can get to them when they need them, and then change them after it's all done, and then audit this whole transaction. The other thing is that because in a modern data center today, like a cloud, stuff is coming and going. If you deal with a typical multi-tenant environment, there's customers coming in, customers going, people are patching, people are getting updates. The entire landscape of services, COM objects, DCOM, MTS, IIS, web.config, databases, database accounts, and even credential providers is changing constantly in a modern environment. So the objective is to stay up with it. So I would make the following statement to you. Security is about coverage. If you have one weak place in your security, that is the place that a hacker will try to find. The more things that you fall behind on, that is, the more things change in your environment, the more places there are to open up holes. So the objective that we see is what's known as continuous compliance. So for many of you, the idea of the auditors coming in is not a happy day, is it? Because they're always asking for this data or that data, and they're always complaining about things. There's always this wrong and that wrong, and there's always findings. So let me present to you another reality. Imagine a reality where you don't have to prepare for the auditor ever again. And that is because the solution or the way that you're solving your problem, and forget about us as the only solution to do this, but you're on a different regimen, and the regimen is every day your solutions are looking for holes in your environment. They're looking for new machines. They're looking for new identities. They are changing things, and they're looking for weaknesses as they develop, and they close them either in an automated way or they open up a trouble ticket in which a human has to get involved in order to bring the place back into a secure position. So the idea of continuous compliance is forget about getting ready for the auditor. Every day is an audit. Every day is a day that you're trying to make your environment better. And the idea of things like pass the hash really bring up this fundamental reality that people are looking for weaknesses and looking for credentials that will have sustained access capability. But if you keep things changing and you keep things going where you're always trying to stay in control, then what you get from the auditor is a smile. Imagine that. A smile from an auditor, literally saying, you know, you are actually exemplary in what you do. And that's the purpose of continuous compliance. So as a vendor, we want you to be on continuous compliance, and we want you to look forward to the auditor. And in fact, generally, in these types of solutions, the auditor has their own portal to see what's going on, to see if the SLAs are being met. But you're getting constant trouble tickets about anything where the SLA isn't being met, so you're closing them anyway. So automation, I don't know how many of you saw the keynote yesterday. One of the things that was mentioned by Brad Anderson was the idea that for Microsoft, everything is about TCO and everything is about automation. And we agree. And that is that via automation, you can achieve TCO. And via automation, no matter how many VMs you have, if it's all automated, what difference does it make? It's not like a human has to get involved. So whether you have 10 machines, 100, 100,000 machines, or 10 million machines, if it is all automated, then you should be fine. Now, there are some corner cases. As you get to different tiers, there are some new challenges that do come up. So that's what we do. We do this by automation, and we're an N-tier application. So as you might expect, we scale up into these cloud environments. So let me move forward, and let's talk a little bit about System Center. So what is it that we're doing with System Center? We've been a Microsoft partner for a really long time. And we thought to ourselves, wouldn't it be kind of cool if from within System Center you could gain a privileged access to a particular machine? And the other thing that we saw is, well, wait a minute. Some of the System Center products have embedded credentials in them. If we change them, System Center isn't going to know about them. So that's not a good situation because then it's going to be unable to manage. So we thought about how could we tie this together. And then finally with SCSM, we saw trouble tickets as another type of authentication system or another approval or workflow system to decide who has access to things. So let me show you a little bit about what we've done. So the problem is this. If you're running SCCM or if you're running SCOM, if you get an outage, let's say a particular machine is doing something goofy, generally speaking, you need to get into that machine, and you need to get into it not at user level, but usually at administrative level. Not always, but administrative level access is one of the core requirements for a lot of break fix. So many organizations solve this by putting all of their credentials on Post-it notes and then putting them up on, the people who are running System Center. Not a good idea, so let's not talk about that. So the point is you want to be able to get to these machines in a hurry. You want to get to them in a secure way. And you may not want to use your particular ID. You may need to use a specific service account to get in. And the reason being is that if everybody knows the credential and it's easy to get into it, then maybe bad things might happen. So what our solution does is right within the SCOM interface, if you see a machine that you want to get into, you just right-click on the machine. You request password access to that machine. And what it will do is it will pop up a screen asking you to re-authenticate. And then it will go ahead and give you the credential to get into that machine right there and right then. And what's really cool about it is it only takes 5 seconds, 10 seconds to get the credential. And the really cool thing is that when you're all done, you don't have to fill out any paperwork. It'll actually change the credential automatically in the background. So all of the closed-loop nature of this is done. Plus, it also does the paperwork, which is it will actually put all of the audit log entries in for this particular access, including the reason why you did this. And so it provides compliance, but without a lot of pain. Okay, so SCCM, it's kind of the same situation where if you're trying to do remote management of machines or you're trying to do configuration management, this does exactly the same thing. And that is it gives you access to any machine that you see by right-clicking, requesting the credential for it, gives it to you for a period of time, and then afterwards changes it, and then all the paperwork is done for you automatically. And all of this is audited. So this is the well, that was the SCCM. Now, this next part is kind of cool. And actually, all of this is kind of cool, but this is kind of an interesting issue. Most companies today use trouble tickets. So why? Well, it's part of an ITIL process. You want to make sure that there's a reason why people are doing things. It's used for chargeback. And one of the early requirements that came up with many of our customers was before you give somebody super user access to a machine, they should have a trouble ticket on that machine. There should be some reason for them to get into that machine. So we thought, you know, this is a good idea, but what early generations of these types of solutions would do is they would allow you to enter any trouble ticket you wanted into the system, and it was just there for accounting purposes. So I asked one customer, you know, I can see how you could game this. Is this a really good idea? And their answer is, well, yeah, if they game it, we'll fire them. We go, well, how are you going to know? And they said, well, we caught 5 people last year doing that, and we fired them. They go, well, might there be a better way? I don't know. How about if you check the trouble ticket number? And they go, wow, no, that's too much work. We'll just fire them. And I go, okay, well, that's not going to be our customer. Okay, fine. So what we did is we decided to do a couple of things. First, when you put in your trouble ticket number, we go, that's interesting. So we now know your name. We now know the trouble ticket number. We know what machine you want to access. So we actually go back to the trouble ticket system, and we see if there's a ticket open in that name, is it you that's on that trouble ticket? Is it open? Is it pointing to that machine? And if everything looks good, we go, okay, so this looks legit. Let's update the trouble ticket saying we've given access to this machine, and then we let them in and give them access. So this is an example of an SCSM integration in which we make the workflow of the trouble ticket be integral to the ability to gain access to a machine. So it somewhat enforces this level of control. So let's talk about new stuff. Everybody loves new stuff. Yes, sir.
Quick question.
Sure.
Do you also integrate with other ticketing systems?
So the question is, do we integrate with other ticketing systems? And the answer is yes. We integrate with HP Service Manager. We integrate with BMC Remedy. We integrate with ServiceNow. We also have an open interface that actually allows you to integrate with any trouble ticket by sending it in email that contains an XML payload that's XSL editable. And then we also have an API that you can use that also ties it in together. But since this is a Microsoft event, only Microsoft things are wonderful, right? There are no other vendors. Okay. So interestingly enough, this new capability has a lot to do with a particular company that we're working with that you all know that has a large set of data centers in the world. And the issue that they had was that they had a lot of machines. They have a lot of employees. They have a lot of customers. And they have a lot of hardware. They have a lot of software. They have a lot of hypervisors. And they are everywhere on the planet. And they want to be secure, and they're constantly being attacked. And they understand privileged identity management really well. They do understand the need. But the problem is, how do you do privileged identity management at the scale of literally tens of millions of systems? How do you manage so many credentials? So the model of our product is you have a Win32 GUI, and you have a web interface. And you go, okay, that's great, and it has auto-discovery capability, so it actually finds the machines, finds the credentials, and all of that. The problem is, when you start to get into really crazy big numbers, you actually don't have the time to actually even interact with a web interface anymore. Literally, that's just not even possible. It's over. So you need to come up with a new paradigm, a completely different way of dealing with this. And so what we're announcing here is a new capability, which is essentially security as a service for privileged identity management. And the way this is implemented is it's implemented as a SOAP web service, and it's also implemented as a PowerShell interface. Because it's a PowerShell interface, it directly interfaces with all the System Center components as well as with Orchestrator. It was actually designed in mind with what Orchestrator does. However, for the scale of what we're doing, Orchestrator is not necessarily the most rational solution given the scale that we're dealing with. It doesn't mean we can't use Orchestrator. It just means that it's not used at every level of everything that we're doing with the product. But nonetheless, it is PowerShell. And as PowerShell, it does give you the ability to do all this discovery, permissioning, and all the rest. But I'll talk more about what the details are of it. The product, with the release that comes out at the end of this month, has everything we already have, but these extra capabilities. So what you're looking at right now is something no human being outside of our company has ever seen. This is the WCF container of connecting to our web service, showing the different APIs that are available that effectively turn inside-out privileged identity management and expose it as an engine. So people see things as applications. But we run into a situation as we grow into the cloud and as we grow into large data centers where you have to move beyond the concept of an application, and you have to now think of things as engines, things in which you tie them into your existing processes, into your existing applications, into your existing line of business. So effectively, what this becomes is a platform. So as strange as it sounds, the evolution that we're seeing is security becomes a platform that people write to in order to do things like get credentials, to be able to store certificates away, to be able to get certificates and the passwords for those certificates securely, to be able to add new machines into the environment, to change LDAP paths, to change delegation models. Effectively, all of this turns into being effectively a platform. And so what we're seeing is the evolution of security as a platform for application developers and for line of business operations, which is a real turn of things. But it's really the only way you can scale in the cloud and at the types of scales that we're dealing with. This is an example of a little quick PowerShell script. This is a PowerShell script called Get List of Jobs. Now, what our system does is it actually has a job scheduler, and it has code that will execute certain jobs on certain schedules like discovery, changing passwords, propagation, verification of a credential still being usable and still being authoritative toward a machine for confirming that we still have positive control. So this thing is called Get LS List Jobs. It actually implements a call to that kind of long API in there. By the way, we have IntelliSense in our product, so it'll take you there. So this is an example of a PowerShell run to get the list of jobs that are running, and what you see is the state of these different jobs that are running in order to do security management in the environment. We do more than just obviously look what the jobs are. We can change them, add them, change the properties of them, change lists, change permissions, all of that's done. So the motivation to all of this is the current existing situation is that modern cloud architectures have tons of certificates in them. They have their own CAs, of course, and you would not believe how badly managed certificates are in the real world. I mean, I don't know what kind of world you live in, but the world that we see is not anything like it appears up on stage. People take certificates and put them in their shares because they pulled them out of the CA and they just like put them sitting out there because they might need them at some point because they've got no place to put them that's secure. And so what ends up happening is red teams go searching through people's machines for certificates, find them, and it's just a bad scene because it's just not a good place to put these things away. And then it's not just the certificates, they'll put the passwords for the certificates in the same place. So you have to have a way of breaking these things up, and again, at scale, you're generating huge numbers of these certificates, and yes, everything might be done in a script, but the output of that script has to be saved somewhere because you might need to go back in with a certificate, for example, to change hardware and put that certificate on the new hardware that has come in to replace, for example, bad hardware. The other issue is that you end up with huge numbers of identities, not just privileged, as you also end up with a lot of other kind of odd accounts used for a lot of odd reasons. And you need to have a place to securely put these things away and get access to them to when you need them, and then change them after they've been disclosed. So there is a life cycle to a credential, a birth, a use, a break fix, and what I would call death, which is when they're no longer needed. And so the objective and really the payoff on all of this is this last bullet point, which is when you take a look at the size of the problem, human management of these sensitive assets on an ongoing basis is just impractical. It just doesn't work. And so that's really what this is all about, and that's why we've been working on this now for almost a year on this project. So there's a couple of other things that are coming down the pike, and one of the reasons why we've been so busy working on this, and that is that when I talk about a cloud provider, you go, okay, well, whoever the name of this cloud provider or cloud providers are, that's great, but what about critical national infrastructure? Think about the cable companies out there and the ISPs. Think about the utilities that are out there. Think about, and now here's the interesting part, at least I find this interesting from a business perspective. How many nodes do you think a power company has that need to be managed? 100? 1,000? Millions, maybe? Consider a cable company. How many cable boxes do they have? How many routers do they have? How many head ends do they have? Think about this for a moment and think about what kind of a soft target this is for a opponent in another country. And when you start to look at the numbers, you start to say, well, gosh, you can't really manage this by hand. So you have to have a different way of doing this. And so that's really what this announcement is about, is how do you do things at this particular scale. And at the end of this year, I pretty much expect that the government is going to lay down the law, and these organizations are going to be forced to actually secure these things. And they're not always passwords. You're right. They can be certificates too, or other things. Anyway. The point is that most organizations fail the regulatory compliance in the cloud. One of the funny things is go ahead and read, we're a member of CSA, Cloud Security Alliance. There's this thing called a STAR report where each cloud provider provides a report on their security. There's a very interesting phrase that you should read these reports for. And the phrase is, we use industry best practices. So think about that a moment. What do you think industry best practices are? The answer is not something you really want to know. It's like, you know, the idea of how does sausage get made, how do laws get made, how does software get made. And in this case, when they talk about some of these security aspects, you may not want to ask the question, but you really should, which is who has access to your systems, how long have they had access to the system, who's had privileged access into my data. These are all reasonable questions to ask and things that you should have the answer to. And the last bullet on this is that, or the last two bullets, is the government is now actually going out and probing critical national infrastructure and reporting back to some of these companies what they're finding. And nation-state attacks, in fact, are looking for these things. We see people footprinting our environment constantly. I mean, how many of you here, and I realize, this is a recorded broadcast, but how many of you here have actually looked at your firewall logs and see how busy people are looking at what's going on in your environment? It's happening. Now, not a lot of people wanted to raise their hand. Maybe it's early in the morning and it's Las Vegas. I understand that. It's hard to get those muscles going. But look, anybody who looks at their firewalls knows what's going on. Everybody knows that people are trying to break in and people are trying to footprint and to understand and look for weak spots. And so that's what they're looking for, is the one weak spot that's out there. So why do people not implement these solutions either themselves by scripting or by something else? And the answer is scale, complexity, cost, history, and the best one, culture. We don't need any controls. You should trust us. And if you put a control in, it's because you don't trust us. Oh my God, wait a minute. It's not that I don't trust you. How about all the people who are coming in and using your account while you're not there? Maybe that's kind of an issue. And so what we see is a culture of hiding these things from auditors. So essentially, they simply don't know that there isn't any security, that in fact everybody knows the password. The other interesting, and these are cultural, political, you can talk over beer and wine about these issues. But the other interesting thing and the other interesting challenge we wanted to take up was the issue of, if you're a cable provider and you've got 50 million cable boxes, so tell me where you go find that solution. I mean, where's the store? Do you go down the Radio Shack to go find the software in a little cellophane pack that will manage 50 million machines? In fact, the question, and this is somewhat rhetorical, think about this for a moment. Where do you buy software to run at that scale? Who makes software to run at that scale? I mean, you may not have thought of it. It's an interesting problem. How many people have taken the level of computer science? Have you ever taken a course that said how to write ultra-big applications? I want to control, pick your big company. So there's an interesting problem here. We're actually in uncharted territory, believe it or not. And if there's nothing you take back from this session, is just simply that rhetorical question. So where do you learn to write programs like that? And what are the patterns and practices to write applications at that scale? And the answer is there aren't any. And so what happens is companies like ours work with the large cloud providers, and we actually try things. We actually see where the limits are of the operating system, where are the limits of TCP/IP, where are the limits of the database, where are the limits of just simply human knowledge predictability in these environments. So interesting problems. So we find that in these engagements, these are actually really interesting collaborations in which we try to move the state of the art in computer science to deal with these. So this is a programmatic interface that we're talking about, and it's a programmatic interface that is designed to be an open platform. And here's the funny thing. When we designed this to not be just Microsoft-centric. We did it using a web SOAP-based service so that you could tie in via any language that you want, and you could push stuff up and pull stuff down in many different forms, not just passwords, not just certificates, but anything that you want to upload, you can, and then anything you want to put the engine against, you can also. So this is an open platform for the orchestration of privileged assets and their usage. So these are some of the things that you might want to orchestrate in a private cloud. One of the things is lists of machines. You might want to, for example, change LDAP paths or tell it explicitly what you want to manage. You may want to let it discover accounts, or you may want to, in fact, provide criteria saying these are the accounts that I want to manage, say, for example, administrator. Or if administrator was renamed, I wanted you to do this by RID. In other words, forget about the name or the language. Just look up the RID, that is the GUID piece of the username. Figure out what it's currently named and manage it. You also need to control the job engine as to what gets changed when and on what frequency. You need to have the ability to do secure upload. And this is another important thing. Putting things away in a repository and having an engine to change things are all good things, don't get me wrong. But the other thing you have to do is you have to programmatically expose the access control system. That is, you have to be able to not only generate secrets, put them away, but also be able to control the delegation model. Because consider this for a moment. If I have a huge data center, people are coming and going, groups are coming and going, and I may want to change how I want permissions to operate. So in fact, the actual operation of authentication and authorization has to be a programmatic interface also. Otherwise, you can't do it at scale. You can't have somebody in there all day long screwing around with the permissions and the groups and how people get to different things. That also has to be automated too. Otherwise, this is not going to work. So it's not just the engine, it's also the automation of access to the engine. And this even goes into identity management as to what types of identities and what types of criteria to those identities should be enforced. The other thing is, and this is another really sore point in cloud environments, one of the things which is not really good about cloud environments is that they have not been very good about sharing with you the audit data that they have been collecting. Let's hope they've been collecting audit data. So whether they are or they're not, let's take that one off the table. But one of the things we wanted to do at the very beginning is to say our subsystem as part of this cloud will have publicly accessible audit data that can be sliced and diced for whomever needs to or wants to see the data. So this is an attempt to provide transparency within security so that the security becomes transparent to everybody out there. So you understand not only who did what, but who set up the permissions to do those things. So this is a PowerShell script that I put up here that just kind of shows you how you automate a particular function in PowerShell using this PowerShell interface or web services interface. This particular one is an interesting thing that many people might want to automate, which is you've just got a new piece of hardware. You've just spun it up. It's a new VM. It's a new machine. It's running the latest version of whatever operating system you want from Microsoft. But now you want to join it to the domain. So in order to join a machine to the domain, you have to be an administrator on that domain. But you don't want to necessarily hard code the administrator password inside of a PowerShell script. So what the first API does is it goes to our product and it says, get ls password with reason. This is an interesting concept. You actually have to have a reason for getting a password for the administrator account of the domain. So there's the reason, adding machine to domain. The next thing is to go and create an object in PowerShell. So this is native PowerShell. What it does, it takes the account and takes the password we just gave it, creates a domain credential object. The third line goes ahead and adds a computer to the domain using the domain credential object. And then the last line, which is the most important one, that I think, at least as part of this exercise, this says, okay, we're done with the password, check it back in. And what this does, this creates a job in the back end to change that password. So that password was a one-time use only password. And so that script has no embedded credentials in it at all. And the interesting thing about this is that the question is, you'll notice on the first line there is a value called $token. So that token can come from a certificate. It can come from integrated authentication. That token can also come from explicit credentials if that's what you want. But the point is that if you're using integrated authentication, then it turns out that whatever the account is that the script is running under, that will be what generates the token. And so there's a little extra line up there that I put in there, which is how you actually achieve the token itself. But the point is, no embedded credential and native PowerShell, and this is a domain access, one-time use credential. This is another script that I put together. And by the way, this entire deck will be available to you for download off of ComNet, so this is not, you don't have to, write this all down. And by the way, the APIs for doing this are available, so we'll give you the email address at the end to contact us, and we can actually send you the SDK for this. So what this one does is this says, change all the local passwords in a group of machines. So this is if I have, let's say, 1,000 machines, I want to change, say, the built-in administrator account no matter what it's been named to. So this program, what we do is we ask our program to do what's called get ls list Windows accounts for system. So this literally goes out and for a particular machine, it will go ahead and give us all of the accounts that we know about for an account for a particular system. What we then do is iterate through those accounts. And then in the last part, we literally just go out and change that credential. It's just really only effectively about 3 or 2 lines of actual code. The rest are just iterators. So rather than doing like a giant eye-test walkthrough of all the code, let me talk about some of the other things that you can do via a programmatic interface for the cloud. One of the other things you can do is you can request credentials, of course. And this is another interesting thing in the cloud, which is sometimes you don't want to provide the credential. What you want to do is say, here's a particular machine. Here is my name. I want you to add me to the local administrators group of that machine. And what I want you to do is leave me in there for some period of time, let's say a half an hour or an hour, because I have work to do, and here's the reason why I'm doing this. So this escalation is effectively changing group memberships for a particular machine for a limited period of time with the idea that de-escalation will occur automatically. Other things, again, these are useful things from the programmatic point of view, the ability to upload certificates, as well as upload the passwords for those certificates. And consider this, that if you're doing this all in scripts, adding these lines to the script to secure the certificates after they've been issued and embedded, as well as the password for it, means that you don't have to put it on sticky notes or put it out on your shares anymore. Now, one of the things I mentioned earlier is that we're showing PowerShell here, but you don't have to use PowerShell since this is a web service. You can use it directly in C# or VB.NET, or if you're using the evil language Java, and notice I prefixed that since we're here at a Microsoft show, you can actually connect to our web service, get the WSDL file. It turns out it's really easy to do in Apache Axis. It works in 1 and 2. And it builds all of the wrapper code, and you can immediately use the service literally within a few minutes. And we also have sample code that actually shows how we do this in these different languages. And in System Center, this is kind of an interesting element, and that is that because it's PowerShell, you can now call these things from within Orchestrator, or within actually any System Center product out there that supports PowerShell. So again, the goal of this was 724 security management. And as we said, this is in fact not only a platform for IT administrators, for security administrators or security auditors. It's now a platform for people who actually want to write code, whether it's easy PowerShell stuff or whether it's hardcore type stuff too. So effectively, what we're saying is this, and that is that PIM, or Privileged Identity Management, can now become a core service of the enterprise. It's something that if you don't want to use the UI anymore, not a problem. You can now deal with Privileged Identity Management absolutely from the API level. So that really takes us to the end of the presentation and also the opportunity to open up for questions. If you'd like to gain access to this code, or you want to try it out or talk about it, you can connect to us via support@leapsoft.com and request access to the beta of our code, which is version 4.83.6. We're expecting GA of the product at the end of this month, but it is definitely available for playing around with. Tell you a little bit about the company. You're probably going, well, who are these guys? Are they like some Silicon Valley VC startup that just got like a bucket of money and now has a great idea and is going to go poof? Well, no, we actually started in 1978, not much later than the founding of Microsoft. We came up with our first ISV solution in 1994. We actually pioneered this field of privileged identity management. We actually tie to a lot of different tools, especially in the System Center arena. We have 1,200 plus customers, many of them in the government. The nature of our company is we're privately held. We're a U.S.-based company. U.S. citizens are the only people who work on the code base. Management owned, and we've been profitable for all of these years. And we have the Doritos model of business, and that is that we sell stuff and we charge money for it, and then we make more of it. And then we make it better year after year after year. So it's kind of an old-fashioned idea. And that's really our business model, is make really cool stuff that works really well at really high scale. We're located in Los Angeles, California, with offices in Austin and other cities throughout the U.S. And we're also a gold sponsor here at the show. You can see us front and center. We have a wonderful magician and also 4 demo stations where you can actually see this code and see our products. And we make 10 different products. A lot of them are for IT administrators, but this is obviously a privileged ID management session, so that's what we're talking about. We are what's known as a managed Microsoft Gold partner, so we work very closely with Microsoft. And we manage privileged IDs not just on the Microsoft platform, but on virtually every platform on the planet. That is both Microsoft's partners as well as Microsoft's bitter enemies. But this is a world of heterogeneous networking. So whether you're a Microsoft customer and also an Oracle customer or a Linux customer, we love open source. We love Linux. We love Windows. We love anything that you buy and use. And we can manage the privileged IDs in all of them. By the way, if you're wondering if it's certified, the product is certified on Server 2012, 2008 R2. In fact, one of the first platforms we certify on is actually the Microsoft platform. So we're testing the betas as they come out, and we're usually ready with our certification well before release. We also manage things like SharePoint. We use SQL Server as our back end. We do network load balancing. By the way, we also manage ASP.NET. We also manage SCOMS accounts. One question people might ask about our product, by the way, is it reliable? Well, it wouldn't be a very good product if it wasn't reliable, huh? So how do we gain reliability? Well, it's actually based on SQL Server. In fact, most of the tables, virtually everything that we do in SQL Server is open. You can go right into the schema, look at what we're doing. The only thing that's encrypted are the passwords. And, of course, the files are also encrypted. But other than that, it's really easy to understand what we're doing. We're also a partner in the System Center Alliance, so we're also an SCA partner, too. So anyway, you can download the product, not just the one with the web services, but the regular product off of our website, and our SCs can help you with that. You can also get it as a Hyper-V image or that other company's image, too, which I won't say on the recording. And then we also have demo environments, too. And we can also set this up. You know, one of the things that's really fun, and I'll wrap this up here with questions, is when you take our product and you connect it up to your network, the first thing it does is it goes and it does auto-discovery, and it finds all of your stuff. Finds your machines, finds your accounts, finds how your accounts are being used. And it does it really fast. We can do, in the latest versions, we're up to about 2,000 Windows machines per minute off of one node, and then you can chain more nodes together to get to whatever level you want. We can do about 1,200 to about 5,000 Linux machines per minute also off of the same node. So it's really fast stuff. But that's not the cool part. The really cool part is after we connect to the machines, pull all the accounts, and figure out where they're using, and then we show people a map of their identities and how they're being used. That's really a cool moment. We call it the run out of the room moment, where they go, holy bleep word, that account's not supposed to be there, and who's using that for this purpose? So we love to show our auto-discovery technology, and then they go, well, can you remediate? And then the remediation rate is that same thousands per minute. And then when they see that, they go, that didn't happen. No, I wrote scripts. I can tell you it could not possibly have happened that quickly. It really does. So we love demoing this stuff. So come down to the floor. Obviously, if this is a recording, you can't come down to the floor. You can go to www.liebsoft.com and see our stuff there, too, in case you're watching this on playback. So that's our risk-free assessment where we fire it up for you. You actually push all the buttons, so we don't need to see your passwords and stuff. You actually run it yourself, and then you can kind of see what you've got out there on the network. So it always is an interesting experience. So that takes us to the end of the formal presentation. What I'd love to do, and hopefully I haven't put you all to sleep here. I think you look all pretty awake here. I'd like to open up to questions about this technology, this problem, perhaps our new capabilities. Yes, sir?
How granular can you get with who has access to the permission set? So if you have a netping group controlling the routers, you wouldn't want the Windows group setting up the interfaces in order to change the passwords on the routers, and vice versa, or the SQL team not having access to the local administrator access to the server, but only to the SA portions of the SQL databases, and for IIS as well. How granular can you get when you're setting up who has access to each area to control?
So let me repeat the question. I should have mentioned to use the microphones up there, but I was, remiss in doing that, so I'll repeat the question. The question is how granular can you get in terms of the access controls and the rules as to who can gain access to what? And the example being the SA accounts should be accessible only by the DBA people, whereas, let's say, the routers should only be accessible to the hardware router team or the telecom team. And similarly, the local admin accounts, in fact, consider this granularity. If you're on the help desk, you probably might be good with having access to normal generic workstations, but you probably shouldn't have access to the administrator account of the CEO or of HR or of financial or of R&D. Those usually would require more. So the way the product handles it is we have things broken up into a grouping system that groups machines, groups accounts, groups identities. And we actually consume group memberships right out of AD and then map those to different objects within the storage and access policies of the product. So, for example, you can define this by geography. You can define it by work function. And in fact, the way this works is you simply, within the product, say this group of machines is actually managed by this group, and this group has the following permissions. And that's all. If you're not in that group, you can't do anything. Similarly, logon is granted to this group, let's say, for example, in AD. So in the provisioning system, the way it would work is, first of all, you have to have an account, and you have to be in a group that has access to privileged IDs. The second part is that we begin accumulating things when you log in. The second one, which is what is the scope of the machines? What is the scope of the accounts that you have? So that when you bring up the GUI interface or you operate off of the web service, we look at your identity and we're able to realize an effective set of permissions that control the scope of what you can see as well as what you can do. In addition to that, some machines and some types of accounts and some types of permissions require workflows, meaning that you can't actually get there. You're allowed to request something, and then that request will go to the owner. The owner has to approve it, and once approved, then you can gain the access. So the answer to the question is that you have to have incredibly fine granularity in order to actually implement this in a way so that you get the minimal amount of what you need. That is the right things you need, not even the minimal amount, the right things you need, and no more. But you have to be able to get to them quickly, so we don't slow you up. If it's something you're supposed to have, you get to it immediately. If it's something that is sensitive, that you might need access, then we need more people involved. We also have a concept in the product of also known as double safekeeping, which means we also break up passwords, saying that you're allowed to have one half and another person out of another group is allowed to have another half. So we have the idea of breaking up secrets into multiple pieces so that one person doesn't see it. We also have the concept in the product already built in of one person to one identity at one time, as well as the ability of one person to one identity who can then grant it to more people or to a group, but then this becomes an attributable activity so that you understand who has access. The other thing is the ability to accumulate more than one credential at one time in order to achieve a certain work product. So the idea of not only who, but how many, what parts of the password they get to see, as well as what kind of access and whether it's single or multi-factor, depending on what they're trying to go after. So it's sorry, it's kind of a long answer to a short question, but granularity and access controls in an enterprise or in a government become complicated really fast. And so you have to be able to map onto it. And so we've mapped onto AD for the most part, but we can get permissions from other places besides AD. Did that answer the question?
It was more or less on the side of it.
Oh, sorry.
It was more or less when you're setting it up right in the very beginning, making sure that I guess that only the networking people have the ability to set up that function at the time of install.
At the time of install. So at time of install, that's kind of an interesting question too. So we took the Microsoft model. The Microsoft model is initially when you start it up, you can do anything and anybody can do anything, but there's nothing in it. So the first thing the person installing it does is set the initial ground rules. So effectively, it's a set of rings that at the beginning, there are no rings. But as time goes on, as you're beginning to deploy this, you begin to provide more granular delegation as to what people can do. So we start out with an easy model, but then when you bring up one of our dialogues, you will see a mind-numbing number of checkboxes and a mind-numbing number of different group memberships associated with different privileges within the product. And so it starts out, you can do anything you want, but before you turn the switch and actually put anything into it, you actually have to set the permissions. You don't have to. Not a good idea to not do it, but it's something that as part of the deployment you have to do is figure out what the delegation model is going to be. And it's pretty flexible. But just because it opens and starts insecure doesn't mean it's insecure. It just means we want to get you up and going initially. And again, you can run our product without encryption. Why you'd want to do that? Not a good idea. But we do that because it's a starting point, because you have to pick an encryption system. So once you picked it, it'll then crypt everything at that point and stay crypted. So with many things, we want it to be easy to get started, but then you have to turn on the functions you want in order to provide the appropriate security. Other questions?
Good morning, Mr. Lieberman.
Good morning.
I see situations where somebody has like 10,000 different servers at any given time, and during that month, maybe 100 will come offline and 100 new ones or devices will go on. How does your auto-discovery address that?
So the answer to that is the product has a direct connection. It's actually a hot connection to both the authenticator and to the directory. And what it does is it's constantly looking for changes in the directory. So if it sees a new machine in the network, it has both a push and a pull model. In the push model, you can embed in the VM image, the moment that it arrives up on the network, it will actually run a script which will announce itself to our solution and say, I want you to manage me. The second thing is if you don't put that in there, it somewhat doesn't matter. There's a little bit more latency. But what we're seeing in AD is when we see new machines in AD, we will add those to our refresh jobs automatically and begin to discover the accounts and also be able to discover how those accounts are being used and also begin managing them immediately. The other part that's interesting about it is that a lot of people try to change service accounts and stop doing it because it causes outages. Now, what is the reason why you get outages? It's actually related to your question. The reason why you get outages in service account changes within Windows is because you missed one service somewhere. So one of the things that we did philosophically is we said, you know something? We have data about services. We have data about where these accounts are being used. But when it comes time to change the password, we're going to throw all of that out. What we're going to do is we're going to do a rediscovery in real time of every machine that you have in the group. And we're going to find every service account usage at that point. And then we're at that point going to change the services. So the point is that we also do auto-discovery immediately through LDAP or AD to find everything that's out there. And by the way, we can get machines not just from AD. We can get them out of any CMDB like SCSM. So we can actually aggregate them together, too. So we can aggregate not only AD, but other sources. But the important thing is that when it comes time to change your credential, we change the credential, and then we rediscover where all the usages are in the environment, and then we then change it in all those places. The other thing is, have any of you tried to change service accounts in a script, like using Service Control Manager? And you've probably noticed that it works about like 90% of the time. It depends. On a good day, it might work 100% of the time. On another day, like nothing works. It's usually how critical it is to get done as to how many of them work. So in our code, you ever heard the term secret sauce? It turns out that there's a lot of really interesting corner cases with service account management. In fact, in general identity management. So what you're paying us all this money for is to actually be able to change that service account successfully. So what does that mean? It means you got to do a dependency graph analysis of the service, figuring out what's dependent on it. And then you have to stop them in the proper order. And then you make the change, and then you restart them in the proper order. And you know, sometimes no matter how good your technology is, you may not be able to succeed because the machine may be sick. So what we do is we go crazy, trying every strategy we can, and we have lots of them to do it on both clustered and non-clustered services. We do everything in the book. At some point, the machine is beyond all hope. And at that point, what the product does, it opens up a ticket saying, I give up. I got nothing left in my bag of tricks, and that's a good thing. Some people would say, well, if you're so smart, why don't you just reboot the machine and then try it again? And the answer is, we're so smart, we're not going to reboot the machine because there might be stuff running on that machine. You'd be really, really, really pissed off at us if we restarted one of your machines just to succeed. So we're very polite. If we see a service that's down, and we change the credential, we leave it down. If the service is up, we bring it back to the up state. If whatever the service is, if it refuses our commands to change things successfully, what we do is we try and try and try and try, and then eventually we give up and then open a trouble ticket for you and say, you need to go look at this because something is going to happen, and somebody has to make a human judgment. And in fact, you know, all the stuff in cloud that you're looking at that we're talking about this morning, it's all designed to automate everything you possibly can. But every single verb in our solution, and there are hundreds of verbs in the web service, all have this idea that automate everything you can. But at some point, if you can succeed, you need to bring a human into us. A human is the only one that can make a value judgment as to what to do, especially if what they need to do is a reboot or power cycle the machine. So that's the philosophy of the entire product, is automate as much as you can, but in anything that you can, bring the human into the equation. So effectively, for most of our installations, there's like one FTE who gets involved maybe an hour or two a month to look at these things, and the rest of it goes down to the IT help desk where we simply have machines that have issues that need to be opened and looked at. So we close the loop. Again, it's all about continuous compliance. Let automation do everything that it possibly can, but when automation doesn't do the trick, then you have to bring a human in so that you can close the loop on that continuous compliance virtuous cycle. Humans are good at a lot of things, but you know, doing the same thing over and over again that comes with the same outcome is something better left to automation. So that brings us, any more questions? Well, I want to thank you so much for attending this morning, and have a great day. Oh, by the way, don't forget to fill out your evals because you can win prizes.